Hello, welcome to MariaDB Server Fest. Today I'm going to be talking to you about MariaDB SkySQL, a new database as a service offering from MariaDB Corporation. And first things first, I want to introduce myself. My name is Rob Hedgpeth, and I work a part of the developer relations group at MariaDB Corporation. And essentially that means I do anything and everything that I can in order to take the developer's journey and experiences and make them as positive as possible when working with MariaDB. And a lot of times that involves creating content from webinars to sample code, blog post, anything and everything that I can use to really help developers of all kinds in all learning styles basically get up to speed with MariaDB. If you think at the end of this session you'd feel like providing me with some feedback, asking me any questions that you may have after this, please feel free to reach out to me. It's my email, robh@mariadb.com. You can follow me on Twitter or message me on Twitter at probablyrealrob. And if you feel so inclined after seeing some of my code, want to either judge me or follow me, you can find me on GitHub at rhedgpeth. All right, so let's go ahead and jump into this. As I mentioned, we're going to be talking about MariaDB SkySQL, and we're going to take a look first at some of the slides and dive in really to, from a high level, the architecture of how SkySQL was created and planning on being used across multiple different cloud vendors in the future. And then we're going to take a look at some of the capabilities that are provided in SkySQL. And this really helps us set up the foundation that we can use then to jump into some sample code and start looking at demonstrations of not only connecting to and getting started really using SkySQL, but specifically looking at HTAP, or what's known as hybrid transactional analytical processing. And from there, we'll take a look at a third-party integration tool known as Jupyter. It's a notebook application, and we'll see what we can do from an analytics standpoint or a data science standpoint with some large data sets that we're going to be working with. But let's go ahead first and start by diving into MariaDB SkySQL. Well, first things first, of course, is we need to understand what SkySQL is. As I mentioned and said in the title, it is a database as a service. Now, you probably know what a database is, right? Well, if you're at Server Fest, you most likely know what a database is, right? Because you're such a fan of MariaDB, which is awesome. And you can think of a database really as the simplest sense of, a bucket essentially holding something, right? And essentially that something is then persisted, right? So you've got this persistent data storage, and that is the simplest sense of what a database is. Now, this cloud in the background essentially represents a DBaaS, right, or a database as a service. And its job really is to provide a layer of abstraction for the database itself. So being able to allow users to use the database without having to worry about things like provisioning machines, installing or maintaining and updating the database, and a variety of other things that goes along with having to install and ultimately maintain a database long term. And obviously, if that's a database as a service, then if MariaDB SkySQL is a database as a service, then essentially this bucket, we can just give it the logo of MariaDB, right? And that's ultimately what SkySQL is, right? But you may be wondering, what's really the difference between SkySQL and Azure databases and Amazon RDS, right? All of those things have MariaDB or flavors of MariaDB. And the main difference from the highest level really is that MariaDB SkySQL runs using enterprise server bits, and RDS and Azure databases run using the community service bits. Now, there's pros and cons, of course, to using community versions and to enterprise versions, and I'm certainly not here to market or sell any of that. But ultimately, that's what the difference is, and we'll see a couple of different ways, especially within the architecture that it's set up, in order to just differentiate really SkySQL from some of the other options that you have out there. And that really starts first with the architecture. If we're taking the highest level view, we're going to look at some of the options or some of the technologies that we used in order to be able to create SkySQL. And you can't get very far into an architecture discussion about SkySQL without mentioning Kubernetes. For those of you who may not be aware, there are these things called containers. And containers can contain any number of things from a technology perspective, but the idea is that they're self-contained, portable, and something that is very popular today, right? And in this instance, we're able to use database instances inside of containers. Well, Kubernetes is a way that you can actually orchestrate or manage those containers. Now, we won't get into the minutia really of things like Kubernetes pods, nodes, and clusters, and talking about the intricacies of that, but essentially we're using Kubernetes, which then helps maintain a level of high availability, among other things, along with MariaDB SkySQL or MariaDB database instances. And so the combination of these two really provide a very robust and modern approach to being able to create what is the groundwork for database as a service. Now, Kubernetes also has an API which we take advantage of so that we can use cross-cloud service providers, right? So if you think of Azure, you think of Google Cloud, and you think of AWS, we're able to use our Kubernetes approach across different cloud vendors. And that really allows it to scale. Now, on the other side, or the other end, we have a front end, and that is powered by something called ServiceNow. Now, it's not necessarily important that we dive into what exactly ServiceNow provides or offers, but essentially what we're using it for is the ability to both configure and manage the inventory and the workflow of the MariaDB instances underneath the hood. And we've peppered in some very awesome kind of modern technologies, open source technologies in Prometheus to handle event monitoring, and Grafana for some visualization, as we'll look at some real-time monitoring of the database that we can do using those tools through SkySQL. From a separation of concerns or a more modular aspect, we use a portal or a front-end portion. We have what's called a control plane, which we'll dive into a little bit after these bullet points into more of an image view or an architecture slide view, which then helps us communicate with the database or underlying databases that live within the Kubernetes cluster. And all this is really done to provide a high level of compartmentalization, of course, with the modularization, isolation, and ultimately a way that we can control indirect access, right? Even with ourselves, of being able to access the databases that live within SkySQL. Now here is a high-level view of what SkySQL looks like from a user's perspective, right? If you start from the left-hand side, you can see that what we call customer admins or users, right, log into a web UI that allows them then to be able to control the workflows and the inventory, right, of the databases that, if you look on the very right-hand side, live within the Kubernetes cluster. Now, there is some layers in between there, and that's that control plane that I mentioned before. And its job really is to, of course, relay from left to right, we see here, relay the tasks that are created through any kind of inventory or workflow management into the control plane, which then is going to translate that information into commands to send to the Kubernetes cluster on the very right-hand side. And from there, we can gather everything from, of course, database results, metrics that we can use and flow back into the UI and visualize using those open source tools that I mentioned before. But almost most importantly is the ability to provide indirect access for our SkyDBAs. Now, I'll dive into a little bit more of what it means, the term of SkyDBA, but essentially you can think of it as a MariaDB professional database administrator, right? And they're going to log in using an identity proxy and through a jump server to gain access to the database instances that live within those clusters. From there, they're able to perform a lot of the roles that you would imagine DBAs can, but again, from indirect access, never having direct access to the database itself. Now, from a customer side, you can access the database through a firewall, which we'll dive into as we get into the demonstration a little bit later on, through your applications and third-party clients, and even the MariaDB client, as we'll see a little bit later on, to actually access the database. But that's the overall gist. Now, obviously, all of these things are cross-cloud service provider, as you see at the very top here. So the intention is that this would work exactly the same for AWS, Azure, and Google Cloud. You would just be picking a cloud service provider ultimately whenever you want to use SkySQL. Now, on the other side of that, we have our services that define more of what's available from the actual database as a service part, right, to show what's available from the service of SkySQL. And that really starts from a topology. When we think about how we write code or how we may write applications, a lot of times you don't necessarily have to use the same kind of environment for your production servers as you would for your development or your test servers, right? And so we have different topologies to accommodate this. And on the left-hand side, you'll see that we have a standalone instance. And that standalone instance provides us with the ability to create maybe a test or a development environment. And it's going to come with a variety of functionality that, of course, are available within a multi-node setup. But some of those include transactional, more traditional row-based databases that you can spin up services for if you think of like InnoDB. Analytical services, so if you think of column store, if you're familiar, which we'll get into a little bit more of the details, or even a combination of the two where you can actually combine both transactional and analytical storage on the same server and then even run single queries against those using HTAP, as I mentioned before. And this all is kind of rolled up and available to be able to have real-time monitor against it as well. Obviously, you're going to want some form of configuration because, as we know, MariaDB has a pretty robust collection of system variables and configuration parameters, essentially, that you can set in order to make it tuned and run really well for your workload. We wanted that to be available, of course, within SkySQL and highly customizable, as we'll see once we get into the demonstration. With any professional database, of course, there needs to be disaster recovery and automatic backups, which happen nightly. Point-in-time restoration, of course, if you needed to go back in time to restore your database at a certain point. And as I mentioned before with Kubernetes, there is the ability to provide this high availability through something called self-healing. Essentially, when a Kubernetes pod were to die or go down for a variety of reasons, then it would self-heal itself so that pod would spin back up and be able to be very resilient that way. On the other side, or on the right-hand side here, we see a more multi-node setup where you'd think of a production environment. And in cases like this, you can use something that's in tech preview now through our expand product, which is called distributed SQL. And distributed SQL is basically being able to take database and spread the information out using this thing called a slice or slices onto the machine or the nodes for massive amounts of information, right? So we're talking billions, tens of billions of records being distributed throughout these nodes. And we'll see that as an option as we dive into the SkySQL portal a little bit later on. Of course, even more high availability, right? So as you create more nodes and you have these primary replicas, you have, inherent advantages, right, from the cloud service providers through multi-node deployments and replication. There is a product in MariaDB called MaxScale, which you've probably heard of, which is simply just a database proxy. Not simply, it is at the highest level of database proxy. And of course, that provides all kinds of capabilities like automatic failover, transparent query routing, read-write splitting, and a variety of other features, which it's good to know about, but we're not going to dive into as in depth with this particular session. And lastly, before I jump into the demonstration, I want to talk a little bit about SkyDBA, as it is a distinguishing factor about MariaDB SkySQL. Essentially, as I mentioned before, you get the MariaDB professional database administrators, which provide everything from consulting types of support, which include health checks, performance analysis, and security audits. But the main takeaway here is that when you think about a database administrator, it's very rare that you get a situation where the actual professional, so the company and the group that built the database, provides database administrators as a service, right? And you may find that in, if you think of other, cloud databases like Mongo, right? Mongo's Atlas. You may find it in situations like that, but it tends to be a very sought after type of service because it's rare that you would find that professional that works for the source that's actually building the database as well. Okay, and that brings us to our demonstration. So what we're going to do first is we're going to dive into the portal of MariaDB SkySQL, and I'm going to take you through a tour where I'm going to show how you would look first at launching a service, a database service that you can use, and what all is really entailed in setting up that service and how easy it is to get done. But beyond that, we're going to take a look at some of the other features that start to distinguish SkySQL from other databases as a service that exist out there. And then that's not to say, from a sales perspective, but really just this exists here, and this is why we think it's important type of perspective. And then we're going to take a look at a sample where we build two databases, and in those two databases, we're going to provide two different types of tables, right? Where we're going to be looking at NODB tables, and we're going to be looking at column store tables to combine into an HTAP instance that we can use to show off the power of HTAP within MariaDB SkySQL. So let's go ahead and flip over to SkySQL. All right, so this is the portal, again, powered by ServiceNow for MariaDB SkySQL. You can reach it by going to cloud.mariadb.com/SkySQL. And when you do, you're first going to be asked to actually launch a service. So the screen is going to look very similar to this, where it's going to ask you to launch a service. And you've got a couple of different options here. On the very left-hand side, you've got the simplest example of a transactional based system, right? Where you're using row-based data storage that stores the information in persistent block storage. Next to that, you have something called analytics. And analytics is simply looking or storing analytical information that exists in MariaDB column store. So a columnar database, which is different, of course, than a row-based database, but is really more for looking at large amounts of information without indexes in more of an ad hoc fashion. And there's a couple advantages to being able to use columnar storage, obviously beyond the performance implications that you get. It's also stored within low-cost object storage for each of the cloud providers. So it's a little bit different than the way you would store transactional information in persistent block storage. You're actually able to store this in object storage. And then on the very right-hand side, you can see that we have this both option. And in parentheses, it says HTAP. And that stands for Hybrid Transactional Analytical Processing. And that essentially is the combination of transactions on the very left-hand side and analytics in the middle portion here. And being able to combine both row-based and column-based data storage mechanisms in a single query, which we'll certainly get into. And lastly, something that I'll mention, but we won't really get into too much, is the option at the bottom, which is still in tech preview, but it's something called scale out transactions. And I briefly mentioned it before, but this is this idea of distributed SQL, where you're able to split large amounts of information over multiple nodes and be able to still have a very low latency and high availability available to you within the service itself. So if now we want to go ahead and launch a service, let's go ahead and start by looking at transactions. So I'll click launch, And it's going to, of course, give me a description of what transactions is in the form of MariaDB platform and on MariaDB SkySQL. But the first thing that we're going to see is that we have a topology which allows us to pick either a standalone instance or a primary replica setup, or that multi-node instance that I had mentioned before. Now, for this demonstration, we're just going to go ahead and stick with standalone, as we're just using this to basically develop on or to test some of these integrations with. Next, you'll be prompted to pick a region. And we've got, as you can see, 3 regions within the US, 1 in Asia, and we have 2 regions within Europe. After that, you're going to hit probably the most important part of this selection process, which is looking at the resources that you want to use for your database instance. And that's going to be based on 2 things, right? You're going to have the amount of CPUs, or virtual CPUs and cores in this case, and the amount of memory that you want to use. And it ranges from everything from 4 CPUs by 15 gigs all the way up to 64 by 416. And on the right-hand side here, you can see probably the most important part of this table is the price. And it gets drastically more expensive, of course, the larger the machine gets. Next, you'll want to take a look at the amount of transactional storage that you want to have. And this depends, right? So if you're a transactional database service instance, and that's solely what you do, it may be that you want more. If you have analytical and you need some kind of persistence disk storage of some sort, you may pick less. But it ranges from 100 gigs all the way up to 6 terabytes. And of course, has a factor on cost as well. From there, you'll want to pick the MariaDB MariaDB server version. And right now, there's currently 2 versions of 10.4 and 10.5. Because MariaDB was released back in March, and the summer release for 10.5 happened just a little over a month ago. Then you simply pick a service name and click Launch Service. And for the sake of time, in the instance of saving time for the demonstration, I've gone ahead and created some services. So I'm going to go ahead and click Your Services on the left-hand nav, and I'm going to leave this set up because I've actually created an instance that's exactly the same that we're going to use for an example going forward. Now, when you see this, you have a table. Mine just has 1 entry in it. But this table contains a lot of the same information we just looked at whenever we were launching our service. And really, the only thing that really stands out here is a little bit different are the health check in states. And it's simply just telling you what the service is doing right now. And right now, of course, we can see that it's healthy. So we can click on this row and go into the instance itself for more details. Of course, it's going to give us the name of the instance, some versioning information, and then the configuration that we chose. But what's new to us here is that in order to be able to connect to a database instance, we need 2 things. We need a fully qualified domain name, which we see here just towards the middle, and we need a read-write port number. So we need a port to actually access the database instance on. Beyond that, as I mentioned before, we have the ability to add custom configuration. Now, currently, this is a fresh instance, so I haven't done that. But if I wanted to add a custom configuration, I can either click Manage Custom Configurations here, or I can look at the left-hand navigation and I can say Configuration Manager. And I point this out really so that, 1, we can see all the configuration options that are available, at least from a brief glance, but also to note that there are already some defaults that come out of the box that you can choose and that you can clone, or you can create fresh configuration values altogether. For this, we're going to go ahead and take a look at what I've already created as Rob's HTAP configuration. Now, as you saw whenever you first saw, and you can see here at the title, it says Rob's HTAP config 3. If I were to minimize that, you can see that it has gone through a couple of iterations. And that's because every time you change a configuration value or some kind of variable within this configuration set, it's going to version that. And that's important because if we've got multiple database instances or multiple services out there using this configuration, we can upgrade or keep the same just depending on how we want to use this configuration setup. And as you look inside of this table, you can see all kinds of configuration values. Now, they all have a default setting, but if you want, right, you can scroll to the top here and you can click Actions and Edit Configuration. This allows you, through a series of drop-downs, to go ahead and change these configuration settings. So if I go down to the bottom here for my timeout, maybe I want to decrease that 600 seconds, and I can save. And I'll see that I actually then get a version bump. So now we're at v4, and it saves the previous version history. If I navigate back to my services, back into my HTAP demo service, I'm then able to pick a configuration for my HTAP service by picking the little gear on the right-hand side, and then I can choose a custom configuration, which is filtering it based on the service instance type that I'm using, which is HTAP. Can apply it, and it will apply those configuration settings. So pretty easy, but also pretty robust and configurable. Now, from an access point of view, I mentioned before this idea of a firewall. And in order to be able to access MariaDB SkySQL, you're going to have to enter either an IP address or a range of IPs. And that's going to be done by clicking this little pencil on the right-hand side and then simply entering in your IP address. Now, I've already done this for the sake of saving time, and so I'll already be able to access this service. From there, you have the ability, of course, to stop the service, delete the service, and most importantly, for being able to access this service, you want to look at Show Credentials because it's going to give you the username, the original or default password, the ability then to download what's called a certificate authority chain. It's simply a certificate that you have on the client that you then can give to the server to say, hey, I can talk to you through SSL. And then you're going to get a couple of points here which are going to remind you, hey, you've got to add your IP address to the whitelist. Here is some sample CLI you can use with the MariaDB client. And you probably want to change your password to something that isn't as gobbledygook as what we provided, but also is a little bit better than the new pass, which you see here as the example. Now, before we jump into the integration portion of this, I want to go ahead and take a look at the left-hand navigation to point out some of the features that exist in MariaDB and the state of which they're in, but also some of the potential that some of them have. So we're going to start by taking a look at the workload analysis portion that you see here on the left-hand side. And this is still in tech preview, but as we know, workloads can be pretty complex, right? It's not as easy as write first or write only, a read-write based workload. Oftentimes, your workload can change drastically on weekends, on nights, on holidays. And so we've combined some machine learning models with the data that you start to accumulate in your databases, really to understand and be able to optimize the workloads that exist within the databases that are used within SkySQL. And so this is something that's still in development, so I heavily suggest at least reading about it. It's pretty cool from a machine learning perspective, the things that we're looking to do. Now, it's still in its infancy, so it's got a lot of work to go before we can start getting into the optimization and some of the predictive things that we'd like to do with workload analysis, but it's pretty cool. Now, beyond that or below that, we have the capability that I've brought up a couple of times, which is real-time monitoring. Using Grafana and Prometheus, then on the data that you're storing inside of the instances, we're able to do some event monitoring and look at things all the way from the CPU workload to a query analysis to just query workload in general. A lot of really cool things that we can actually look at in a real-time perspective to give you feedback on your databases and the database instances underneath. Of course, those are whitelisted as well, so you would need to add any whitelist IPs for any access that you'd want to have into monitoring or workload analysis. You have the ability to go straight into MariaDB SkySQL directly from this link, and of course, you can reach out to MariaDB support if you need to. And with that, I think it's time for us to actually step into some code that we can use to see exactly how we connect to and integrate with SkySQL, but also be able to use and look at HTAP so that we can check out our second example, which is in Jupyter. All right, so let's go ahead. For this part of the demo, I'm going to be taking a look at a GitHub repository that I've already created in order to pull down and show how we can actually connect and communicate with SkySQL. And then we're going to take a look at an HTAP database to see exactly how we can use things like cross-engine query to look at both row-based information and column-based information. So I'm going to start by opening up a terminal window. And I'm going to do a little bit of a cheater here, and I'm actually going to bring in my git clone command. And actually, I'm going to go ahead and take a look at a specific folder and load my terminal window there. And here, I'm going to actually pull down my repository, clone the repository, so that we can use some of the bits inside to actually communicate with SkySQL, but also create a schema and load the information in there. So let's go ahead and pull down our repository now. All right, so now that I've pulled down the repository, you can see that I've pulled it from MariaDB Corporation GitHub account and a pretty long name here of dev example SkySQL HTAP quick start. So because that's so long, I'm going to use the CD and I'm going to paste in the name of that folder. So once I'm in that folder, I can see that I've got quite a few things between files and folders. But to give us more of a visual appeal, I'm going to actually open up an instance of Visual Studio or VS Code to go ahead and take a look. So let's go ahead and go into my Server Fest directory, and I'm actually going to use this entire folder. Take a look at my repository. And the first place I want to start is by taking a look at a create and load shell script. Now, I've combined everything inside of a single script, right, so that I have the ability to both display what's going on here all in a single file, but also keep the time for the demo down without me having to go back and forth and entering in commands, or even worse, probably typing those out and fat fingering everything. So as we get into this shell script, we can see that I am simply using the MariaDB client, and I'm providing it things like the qualified domain name, the port number, the username, the password, and that SkySQL chain PIM file, which is the certificate authority chain file that I can use on the client to tell the server that I can connect. So before I can use this shell script, I actually need to go back out to SkySQL, and I need to download this file. So I'll download the file. I'm going to show in Finder, and let's actually go and click back over into my Visual Studio Code. I will bring in my SkySQL chain PIM file, and I'm just going to drop that directly inside of my Explorer window. And that's because I relatively use it from this spot, right? The same spot that create and load shell script lives. From there, once I've connected, I want to go ahead and use a couple of files. So I'm going to use a SQL script IDB_schema and CS_schema, and these are going to allow me to create my travel database, which contains my InnoDB tables, and my travel history database, which contains my column store table of flights. And then I'm going to load information into these tables. So I'm going to start by loading airlines, a collection of airlines into the airlines InnoDB table using a CSV file. I'm then going to load a collection of airports into the airports table on the InnoDB side. But then I'm going to actually use a CSV to load about 700,000 records into a column store table on the travel history database. And this is going to allow me to have two different schemas with different collections of tables, but after I load that information in there, we're going to take a look at something called a cross-engine query, where I can actually combine and join tables from the InnoDB side to the column store side in a single query. So let's go ahead and load this script or run this script. So I'm going to start by opening a terminal window. One of the reasons why I love VS Code. So I'm going to open a terminal window directly in the code editor itself. And from there, I'm going to cd, and I'm going to actually attempt my hand at actually seeding into my quick start. Hey, first try. And from there, of course, I have the ability to run the shell script. So now I'm going to cheat a little bit, and I'm actually going to paste in the command, which is essentially just running my shell script and giving it the arguments of my domain name, my port number, username, and my password. So I'm going to run this script, and it's giving me a little bit of feedback here saying that it's created the schema. I've gone ahead and I've loaded both the airlines and the airports information using a CSV. And now I've actually loaded the flights information into the flights column sort table. To confirm this, I'm going to connect using the CLI quick command here of being able to use MariaDB, going to enter in the password, and now I'm actually inside of MariaDB SkySQL. And I can confirm that my script worked by typing in show databases, where I can see that I've added in travel and travel history. Now, to confirm that I've got information inside of travel and travel history, I'll first start with travel, and I'm going to use that database and just go ahead and take a look at the amount of information that's inside of my airlines table. So we've got 30 records that exist inside of my airlines table. Now, if I wanted to be able to use my information that now exists inside of my airlines table with my flights table, I'm going to be using something called a cross-engine query, right? So here I can tell that I have from travel history, since I'm in travel at this point, I can see that travel history, flights, I have about 700,000 records. So if I want to combine that, I can simply, using HTAP, I can simply write a single query, which is going to allow me to use a cross-engine query or cross-engine join around those or using those two data storage mechanisms. So I want to type a.airline. I'm going to create an alias after this, obviously. And I want to get something like the average delay. The average delay from flights. So the departure delay is a field that is held within the flights table. And from there, I want to actually say, I want to use travel.airlines. I'm going to give that an alias of A. I'm going to interjoin that with travel history.flights F. And I'm going to join on A dot something named as an IATA code, which is the equivalent of the carrier, which exists inside of the flights table. And then from there, I want to group by my a.airline for my airline field, and then I can simply, looks like I actually have an issue. Let's see, select airline flights delay from travel, airlines A from inner. I guess I need to actually join the two tables, so you can't just do inner. Means nothing at all, obviously. So I can do inner join. Now, I have the information from both of those two data sets. And I can simply use any kind of, I can modify this if I wanted to order by the actual average so that I can get a little bit easier to read information on the delay itself. Again, I am the best at leaving out words, so we actually want to order by, but then that gives me the ability to look at which actually has the best departure delay, and of course, being able to show, it's a little bit more important to me, which ones have the worst, so I can avoid those particular airlines in the future from, and I could dive into different airports and where that may happen. But this allows us to look at a cross-engine query. Now, doing this through the client isn't exactly exciting. So what we can do is, on the second part of this demonstration of looking directly in the code and communicating with SkySQL, I want to show how we can use something called Jupyter Lab. And Jupyter essentially is an open source third-party notebook application that I can use to be able to run. In this case, I'm going to be looking at Python and using the MariaDB Python connector to connect to SkySQL, bring back the data from a cross-engine query, and then be able to display that using both the log output in code and also a visualization library called Plotly in order to show some graphs with this exact information. So first I'm going to, on this left-hand side of my Explorer window, I'm going to create a directory called Jupyter. And I am actually then going to exit MariaDB in my terminal, and I'm going to back up so that I can cd into Jupyter, and from there I simply want to type in Jupyter Lab. Now this is something that I've already installed, so it's going to work, but the process is extremely simple. So I want to kick off Jupyter Lab, and once I do that, I want to go ahead and remove this here. Whoops, I want to bring up my Jupyter Lab notebook, and I want to create a new notebook. So I'm going to select Python 3, and essentially I just have a Jupyter Labs notebook, which is untitled at this point. I could rename it if I wanted to, but what I want to do is start to incorporate the usage of the MariaDB Python connector to connect to SkySQL, and what that may look like briefly in code, but more importantly, how I can use that information from a data science perspective, right? Use the HTAP information and start to build visualizations that really help me get a better idea of the data underneath. So I'm going to go ahead and paste some things in here for the sake of time, but I'll explain them as I go. So first I'm going to import the MariaDB Python package, which is the connector for being able to connect to MariaDB databases. I'm also going to be bringing in Plotly, which is a visualization library that I'm going to be using to create some graphs. From there, I really want to create the configuration, because in order to connect to SkySQL, I actually have to provide a configuration. And this configuration needs to have SkySQL parameters. So as I look, I actually in here need to provide, it looks like I have the appropriate information that I need to for my SkySQL connection. Whoops. From there, I want to actually make a connection to MariaDB. And I can do that by using the connector and then just saying .connect and entering the configuration, which is going to use the information of my domain, my port number, my username, and my password to connect to MariaDB. Now, all in an effort to be able to create a cursor. The cursor, then I can be able to execute a query, and in this query I'm now going to have the cross-engine query, right? So the exact same or pretty close to the query that I just had, where I'm selecting airline, I'm selecting an average of the departure delay from my flights table based on the joins that I have of carrier. And then I simply want to fetch my results. Now, I can simply output this information, right, by printing it. That's something that obviously that I can do. So if I first go ahead and enter in a function then to call, make sure I get my indentions right in Python or it will not be running. Go ahead and enter in a call to print underscore stats. And this is simply going to print the top 10 of that cross-engine query. But as you can see, incredibly fast, and it's combining the information from both the row-based mechanisms and the column-based mechanisms. But this isn't very interesting to me because from a data science perspective, I really want to start to drill down in that information and use things like visualizations. So now that we've actually already brought in the Plotly code or the Plotly import, now I can actually bring in a method, and I'm pasting a lot of code in here, but essentially what I'm doing is I'm going to be passing in my results, and then from the information that I've gotten from the results, I'm actually going to build both a bar graph and a pie chart. And then I'm just going to simply show those using this notebook and really the power of this notebook to be able to do some analysis in real time. And of course, if I want to be able to show this information, I can simply just add a call underneath and be able to execute. And so we can see that not only did I get my tabular information, but I also have a bar chart and a pie chart, which allow me to take a closer look at the information from a visualization standpoint. And this is really just the beginning of what you can do using tools like Jupyter, or there's other ones like Zeppelin, but they're pretty cool, and it's really fun actually to be able to write a cross-engine query, which combines the information from your row base, which is something that you normally do, but being able to combine millions or tens of millions, billions of rows in aggregations on the analytical side is something as a developer, it just changes the way that you can write applications. So this is something that it's definitely available within SkySQL, but we also recently created a community server release 10.5 that actually includes the same capability as well. And the cool thing about that is that not only do I have samples that you can actually go and pull down from GitHub using MariaDB SkySQL, but I've also, in each of the samples, provided a way that you can connect to the community server container, which exists out in Docker Hub, to be able to do the same thing. So no matter how you do it, I suggest, if you're interested in checking out things like HTAP and looking in some of the newer things that MariaDB has been doing, go and take a look at those developer samples at MariaDB Corporation GitHub /developer-examples. Also, if you want to try SkySQL, it's completely free. You get a $500 credit to be able to start, and you can spin up transactional, HTAP, all of the service instances that we went over pretty easily. And if you have any questions or suggestions for any of this, feedback from me, I definitely appreciate. Please email me either at robh@mariadb.com, or you can email me at the alias of developers@mariadb.com. It also comes to me. Be sure to follow MariaDB if you're not already. And check out, again, the MariaDB Corporation GitHub account where I've put just tons of samples. And thank you very much for attending MariaDB Server Fest. I hope you have a great rest of your conference.